get started. So once again, for you who are just joining us now, welcome to Atta Insights Relearn program. And today's webinar is what big data means for the power generation industry. So today we have two experts, Ian Stewart from Teradata and Miguel Moreira da Silva from REN. Ian, could you briefly introduce yourself and tell us where you're joining us from?
Yeah, thank you, Mark. Carlos, thanks very much to ATO for letting me speak this afternoon as well. Yes, my name's Ian Stewart. I'm based in the UK. Put simplistically, I keep a broad view on everything that Teradata does in the utilities and smart cities sector.
Thank you, Ian. And Miguel, just briefly introduce yourself and tell us where you're joining us from.
Hi, Carlos. Thank you for the kind invitation. I come from Portugal. I'm leading the data and analytics team at REN. REN is the transmission system operator in Portugal for both electricity and natural gas systems. And as a matter of fact, both generation and transmission assets share lots of challenges that I will address today.
Great. Well, thank you very much, Miguel. So, you know, to all of you who are in the audience, we have a tradition here. So, you know, tell us where you're actually joining us from using the chat box. So, you know, go to the chat box and tell us which city or country you're joining us from. And without further ado, we'll start with a presentation by Ian.
Thank you. Just get the presentation up there. Fantastic. Can everybody see my screen okay there? We're good to go?
Yes.
Excellent. Thank you very much. So I'm going to kick off the session today by talking a little bit about the basic types of data analytics that I see as relevant to the power generation sector. I'll also talk a little bit about how one of our customers in particular got started. And a common theme I want to major on throughout is this idea that power generation doesn't need to reinvent the wheel to do more with data. This idea of imitate to innovate, as I put it, I believe there is a lot that can be taken from other heavy asset-based industries into the renewables space. Like I say, I'd like you to consider that as we go through my part of the presentation today. So to start us off then, like I say, I'll just talk about what I see in terms of the main areas of data analytics, the types of usage I see in the market today. I'm going to start off by talking a little bit about what's happening around the famous edge. So I guess all of you will have heard a lot about the edge. There's a lot of press going on there at the moment. Now this is all clearly driven by sensor data, not just in generation, but in other sectors as well. Cheap sensoring and also existing sensor data that's citing high historians, for example, is leading way to a lot of development in the real-time space out at the actual asset level in the field. In addition to that, coming back to the point that Carlos mentioned in the introduction there, back at the control system level, we're seeing a lot more use of that sensor data in terms of controlling loads and starting to bring this more holistic system together, shall we say. So that's all very, very good stuff, but it's only part of the equation, if you like, if you look at what can be achieved with data more widely in the generation space. Supporting that, again, if you look at these other asset-based industries, there is a lot of investment going on in what I call the enterprise, or put slightly differently, this is the offline analytics world, okay? So this is moving a lot of the data created by those sensors out by the edge and in the field, bringing it back to somewhere it can be centrally accessed, and then integrating that with many other data sources in order to make better business decisions, and indeed in order to optimize the operation of these companies from a number of different aspects. To give an idea on a utopian vision for how this end-to-end ecosystem might hang together from another industry, let's think about automotive for a second. So today, out at the very edge, Within an individual car, there are sensors on the car that can sense what the road conditions are like and will change the behavior of the car based on those live road conditions that it's picking up. Back up at the control level, some of those automotive companies are now also enabling cars to speak to each other so they can pass back information about roads in certain areas, given that obviously you have the GIS location of these cars, you know. So if you look at that, you've kind of got a pseudo control system starting to be developed there. That same asset data is then passed back up to an enterprise level where it can be used alongside any other number of data sets to provide improved procurement. They can drive it back into the supply chain, for example. They can start to use it in terms of how they market and interact with customers. So from that, you'll see this end-to-end overall data ecosystem taking place that uses data and analytics in those three key areas that I've outlined. So you have the use of the very edge out at the actual device or asset level. You have the use of analytics at the control system level. And then, like I say, you've got this back office offline use of the analytics up at the enterprise level as well. If we look at what's happening in generation, in my eyes, based on what I see in the market, I see a lot of good work going on out at that asset level. A lot of the people that develop and build the assets, for example, will now ship those assets with data-driven maintenance capabilities that are very, very good at an asset level. Where I think there's been a little bit less investment is back at the enterprise level again. And this is the area I see big data, in inverted commas, if you use that terminology, starting to come into play. And I think this is the area that generation can definitely start to take lessons from other sectors. So moving this on a little bit in terms of the rationale around investing at that enterprise level, I want you to consider this quote here from Michael Porter. For anybody who's not familiar with him, then he developed the Porter 5 Forces model around market attractiveness. So it's a very renowned kind of business entrepreneur and has a lot of very interesting things to say. Now, to put this quote in context, he's talking about all of that sensor data that out at the edge that I just mentioned in the asset space generally as product data, as he calls it. But what he's highlighting simplistically with the comment is that only comes to life if you use it alongside a whole bunch of other data sets. That sensor data effectively gives you a live view on what the assets are doing if you use it real time, or the historic view of what they have been doing up until a certain point. If you use data from work management systems, for example, that gives you the history of who's worked on the data. If you use the core asset repository data, you can understand the specifications, who installed it, when it was made, and all those kind of good things. GIS data will tell you where it is. There are a whole bunch of other data sets that you can use alongside that data from the edge up at that enterprise level to drive value. And if you look at the types of things that have been done with that data in those other asset industries, you can classify a lot of that under these headings that you can see here. Put simply, using that data more effectively.
Ian, sorry.
Reliability.
Sorry to interrupt you, Ian, but sometimes we can't hear you that well, so try to see if you're covering the microphone or something.
Oh, okay, sure.
Yeah.
Move around so much. Is that better?
Yeah, that sounds good, yeah.
Yeah. So like I say, these are just some of the areas in which data can be used to drive improvements. Again, in all of these asset industries, this isn't just generation, okay? Maintenance we know about. Yield optimization is something that we see a lot of investment in terms of the wider asset manufacturing space. Safety, obviously a huge kind of draw in any heavy asset industry. Nobody will ever turn down a safety-based improvement. And from a financial element, clearly the link between what's going on in the asset space and the overall profitability and the regulatory compliance of the asset base as well is key. And again, that's been another focus area for us in those other asset industries. The other advantage of working at an enterprise level is you can use a lot of that data from across a fleet and analyze it more effectively. What we see in generation and also in other asset sectors are a lot of data silos. So people will own certain fields or have control of certain assets, and it's very hard to compare performance of assets and fleets across an organization to give you that holistic view around performance that I've alluded to there. So this big picture is all very well, but you've got to start somewhere. I'll just talk for a few minutes now about a specific case from China, where we worked with a renewable manufacturer, stroke generator, who were getting into big data, as they referred to it as at that time, to give you an idea of how they went about it. Now, you can see some of the figures in front of you there, but I'll expand on it a little bit more. So they came to us in a position whereby they were interested in investing in the types of enterprise analytics that we can provide, but weren't convinced that they A, had the data, or B, understood the value of those capabilities, if you like, to the organization. So we ran a two-pronged proof of concept for them to start with, which lasted approximately 8 weeks. To focus on a couple of specific business problems. One of them was around precursors to major faults on some of the wind turbines. And then the secondary one was looking at secondary faults. So if fault A occurs, what is the likelihood of fault B occurring straight afterwards? So we had very much had a business focus there. But as importantly, we also focused on testing the quality of their data and seeing if big data tools and techniques were in fact something that we thought they could benefit from. To fast forward to the end and give you a short version of where we got to, from a business perspective, we found some very interesting correlations between some of the conditions within the wind park and overcurrent, which is one of the key areas we were asked to look at as part of the work. There were some very interesting insights there around the tension of the yarn and the roping that goes at the middle of the turbines and the angles that was held at, for example. And laterally on the outage work, there were some very interesting correlations that are drawn between the initial shutdowns and then potential subsequent shutdowns. So we got some good results there. From a data perspective, we also managed to verify a large number of the variables that they put into the initial modeling work. We started off by looking at something in the region of 650 unique variables in the data set that we've been given. Of the 650, I believe just above 80, maybe 85, 86 were actually useful in terms of analytics. So that gives you an idea of the scale of the data items that we discontinued the work on earlier on and then pared down on laterally. So from that, they got some business insight clearly. And more importantly, they got an idea of the data that they could use today, the other data that they could potentially invest in terms of the rest of the overall data set of 685. To do more with data going forwards. And I think most importantly of all, they didn't just want to stop with the one use case. They wanted to push forwards and obviously do more with data based on this initial 8-week test program. So coming back to the big picture again, looking to other asset sectors, I've just thrown this reference into ConocoPhillips as an example of a company that I think any power generation and renewable firm could look to for inspiration about what to do with data at an enterprise level. You can see some of the headlines on the screen in front of you there. Put simplistically, they do pretty much anything that we can do in that upstream oil and gas space up at the Eagle Ford site. So if it's something that you want to read up on, there's plenty of information on the web, or obviously reach out to me. I think they're a really good example of what can be done in the sector. And just to close, I just want to major on this one other key message that I've tried to bring out during the presentation, over and above learning from other sectors. We're looking at this enterprise analytics space on the right the diagram that I started off with. Think very, very carefully about how to put it together as something that you can build on over time and something that becomes a strategic asset. We talk a lot in Teradata about the importance of treating data as if it was an asset in the same way you would work with any of your field assets, if you like. You wouldn't build a wind farm in isolation, clearly, and that's not the same way that you should work with data. Think ecosystems, not multiple point solutions. And like I say, based on that, you get these exponential returns from your investments in data and analytics, as I've tried to highlight earlier on in the presentation. But on that note, I'll say thanks for listening to me for the time being, and then pass back to Carlos.
Thank you very much, Ian, for your presentation. Very insightful. So we'll have questions, I'm sure, coming to the Q&A box. So just a reminder our audience. So, if you have questions, which I'm sure you do, please post them on the Q&A box at the bottom of your toolbar. And then at the end, once Miguel has given his presentation, our experts will answer those questions. So, so Miguel, over to you.
Thank you, Carlos. Well, I think you can manage to see my slideshow.
Yes.
So as I've referred previously, you do know that due to unbundling and regulation rules, generation and transmission companies were unbundled in the European Union. Although those companies were in the past a sole company, a vertically integrated company. And Ariane is an example of that spin-off of that unbundling of the power system. But although these two industries, power generation and transmission, are now managed in a separate way in terms of business model, I would say that besides sharing lots of asset classes, they share also a wide set of challenges and drivers when it comes to asset management and data analytics. So I'll firstly make a very short presentation of Ariane. Ariane is the transmission system operator for both natural gas and electricity in Portugal. We also own and operate a distribution concession of natural gas in the north part of Portugal, near Porto. And we have observed, we have managed to introduce large amounts of renewables in the last, I would say, last 10 years, as well as in Spain. And this process of renewables integration, mostly driven by wind power, was a marvelous opportunity to leverage the digitalization. In truth, generation and transmission companies are digital for 2 decades. That's why generation companies and TSOs can tackle data analytics in the same way, because they have smart meters for 20 years, they have automated substations, they have SCADA, they have GIS, they have billing software, as opposition to what happens in the distribution level, which actually will leave bold digitalization in the next couple of years. So when talking about generation and transmission in Portugal, we have went through a large expansion of our system in the last 15 years. Due to the renewables boom in Portugal, investing quite a lot on hydropower and wind power, both the generation capacity and the transmission grid increased dramatically. And here I have a plot that shows that soar in grid and overhead lines length. We have increased nearly 40% of the length of our grid, and the power transformation capacity has more than doubled. And so the company, a transmission company or a generation company in this environment are truly concerned with grid growth, with capacity expansion. So asset management actually was not the major topic around the business. Our capital expenditures were booming quite a lot, and our regulatory model motivated the transmission company to invest in order to connect lots of generation capabilities and generation facilities, mostly wind and hydro. So when we move from a capital-intensive industry, both in generation and transmission business, to rather asset management-driven company, then we start to reduce capex annually, and we start to tackle OPEX in a thorough way. I mean, TOTEX, both capex and OPEX will be addressed as an envelope, as a financial envelope through life cycle analysis. And when we stop this pace of increasing our asset base, when we have a steady asset base, naturally the average age of our assets, both in generation and transmission, will increase year by year. And when the asset age increases, naturally and eventually the O&M costs will increase, and we have to tackle performance in a quite utter way. So we drew a strategy for asset management transformation 3 or 4 years ago in order to bring to Ariane the right capabilities, the right tools to transform the company, road to risk-based maintenance, passing naturally from time-based to condition and then to risk. So this is the typical approach of utilities, mostly in the generation and transmission side. But the most important topic, and which is fairly related with what Ian said in the previous presentation, is the one concerned with the data-centric organization. I mean, a given company, both in generation and transmission, and also in distribution level, when these companies have to manage large amounts of assets, and when they start to observe another type of challenges that are not grid growth, but rather asset management and life cycle costs optimization, we have to provide the right insights when it comes to probability of failure, criticality of each asset in, I would say, in a granular way, in an atomic way. And I'll talk about this atomic perspective in the next few slides. And the outcome is quite business oriented, because we do want to adjust the frequency of our maintenance works according to the condition or the risk of each asset. And we are going asset by asset, not through zoom out analysis. But a typical hurdle in this type of industries is, as Ian said, is the data silos. And it is quite a hurdle, because I would say that in Western companies, in Portugal in particular, I don't know the reality of other countries, in every engineer's laptop there is a data set, there is a database, there is an access or Excel file with lots of variables and attributes. And this is dramatic when we are trying to build a centralized data infrastructure. And it is not only a technological challenge, is a human-related challenge. That's why this data transformation has a lot to deal with human interactions. And when we started to build our strategy for the asset management transformation, we had two options. We could opt for a vendor outsourcing, applying off-the-shelf solutions, and it could be feasible, and it could be also right doing that. But in the end, we have opted for a internal data analytics team development, mostly using open source platforms. But I would say that there is no silver bullet around this topic. Although we have more than 2 years of experience of data and analytics in this business at Ariane, we have to deal with this topic asset by asset. For instance, for overhead lines and port transformers, we are able to develop our own models, algorithms, without requiring any further solutions from the vendors. But for other asset classes, we may buy and acquire solutions from the market. The topic here is, and the key topic here is the one related to the way that vendors interact in this utilities slash software process. Because in the past, when a given vendor installed the black box in our servers, there was no problem, because utilities engineers just wanted to use it and get results out of that. Today's utilities ecosystem is way different. We have data scientists in the utilities, generation and transmission mostly, and they want to fine-tune, they want to calibrate the functions that are embedded in the vendor solution. So this is also a challenge for the software industry. And we have, in the end, built a product line called Smart, and this product line is related with risk management for a set of asset classes that are shared by both generation and transmission companies. I'm talking about circuit breakers, overhead lines, power transformers, etc. Specifically, the product or the software, the model that we have developed for overhead lines, it applies the typical risk model. We compute probability of failure and criticality, and then combine both using a risk analysis. Organizing data, making the ETL, getting right data with no quantity and quality problems is, I would say, the 90% problem around this development. So if we have in the audience data scientists that are very thrilled with this type of job, I would point out that 90% of the job will be quite heavy and dirty, and just 10% it's about sexy modeling and artificial intelligence, etc. So, but it's also funny, even the 90%. This probability of failure deals with the external causes of incidents, of faults, but also internal causes like the asset fragility. And the boldest change that we have applied in the company was the one related with the granularity of our studies. Because in the past, the conventional approach was looking for each circuit, and each circuit can have roughly 100 kilometers length. So it is a very general and zoom out perspective of overhead lines. We started to apply this methodology because we had to get experts on board to give them some comfort on the way that we tackle the problem. But in the end, we have developed an atomic approach, moving from a data set of 300 circuits to nearly 30,000 spans. And getting data for each span was quite a trouble. We had to use quite a creativeness to grab data that are both internal and public data, like weather data, etc. So in the end, we were able to provide to the maintenance team granular information for their O&M plan. Well, this is a snapshot of the SmartL software. Well, we have here the Portugal map of grid and the typical risk analysis, having the probability of failure and the criticality. If the audience is willing to discuss some details of this topic, I can have some chat afterwards. When it comes to the power transformers methodology, it's quite similar to the one developed for the overhead lines, but we have concluded that from asset class to asset class, well, there is no perfect algorithm. We have to make like a benchmark of lots of algorithms and then check the one that is the most accurate for that specific problem. So we have made a business case for installing sensors in our power transformers, because we have offline data, but we found that to fill up our data set, we should include online monitoring. So we are now installing sensors for dissolved gas analysis, for temperature, for bushings, and most of the decision variables related with power transformers. But even when we deal with sensoring, we have to bear in mind that there is a threshold. Let's say, if we want to optimize O&M, we can install sensors, but we don't want to replace O&M costs by O&M costs related with systems. So there is a limit. After that, it's not worth installing sensors. So we have decided that there is a set of variables that are worth monitoring real time, but the other type of variables will be monitored offline. We have a data set of nearly 2 decades of records, both for oil, electrical insulation tests, performance, skid operation, etc. And then I would say that the science on this model is not on the algorithm itself, is on the feature engineering, the normalization, the definition of synthetic variables, because we have to reduce the set of variables in order to have workable algorithms in our machine learning process. So we have applied so far for the power transformers both models, a clustering model and a regression model. The regression model basically gets information and assessment from an internal expert on the power transformers health, and then we use our attributes that are in the data set, and we use this expert information and we try to get an algorithm that learns with experts, bear in mind the data that we have, and then we apply it to a test case. So here in the regression model, we try to find out like a probability of failure. In the clustering model, we try to we try to populate in different clusters of transformers assets that share data among themselves. So we don't have a probability of failure. We have sets of population that share the same attributes, same problems, I would say. That's useful for maintenance engineers that don't want to go one by one per asset, but want to address a maintenance plan with bulk information, with a cluster of power transformers. So long story short, I would say that it's worth setting up a dedicated team for data analytics in a generation and transmission company. These companies have good data sets because they went digital a few years ago. And the most important advice to raise is to manage the board of directors expectations, because these are just decision aid models. These models are developed to support grid planning, O&M teams, asset management. They are not built for replacing human decision. So far, I think we have to manage these excitement around artificial intelligence. We are in the very beginning of the process, so let's manage the excitement of our board of directors. And that's all, Carlos.
Great. Well, thank you very much, Miguel. Very interesting point you've made right there at the end about managing expectations around artificial intelligence. We'll get to that later, but we actually have time for questions. We have now 2 questions, which is great. So the first one, which is I think is very valid, is by Javier Lillo, and he is asking whether big data is a technology only that's suitable for large companies, or whether medium-sized and smaller enterprises in the energy sector could benefit as well. Who wants to go first? Who wants to have a go at answering Javier's question? Ian, please.
Let me mute myself. Yeah, I'll have a first go at that one. So in terms of the value of data, people get very hung up on quantity a lot of the time historically, and obviously quantity is associated with larger organizations. So the theory goes that the larger organizations have more data, hence this is more for them. Yeah. The reality is that the value of data varies massively based on any number of variables, and also in terms of the financial use cases that you can implement as well. I would suggest that regardless of the size of the organization, any of the areas that Miguel and myself have covered today could be addressed using big data to any degree, In terms of the solutions as well, I don't think it's the case that the actual solutions you need to invest in require large capital investment anymore. Typically, you can start off from like tens of thousands of euros as opposed to having to invest hundreds of thousands to get anywhere. So I would challenge the premise of the question. I would say any company can benefit, and I would say choose your business problem and then work out your technology policy based on what it is that you want to do.
Thank you, Ian. Miguel.
I agree with Ian, and actually I've seen lots of small companies, SMEs, developing big data solutions, mostly in the retail level, for consumer analytics, for instance. And I think nowadays, large companies, of course, can apply this type of big data tools going to Teradata Solutions and other vendors, because they can afford a rather professional and corporate solution. But nowadays there are a wide set of open source models that can address big data in a quite cost controlled way.
Okay, well, that's very, very interesting. And you mentioned something that I think the most interesting points you've made today actually have to do not so much with the technical aspects around big data, but also around the human and management aspects. So how do you choose a problem that you're going to tackle with big data? How do you get people to actually feed the data into the system, as opposed to keeping it to themselves? So I'd like to, cover some of those aspects in our questions. Talking about a point that Ian made at the very beginning of his presentation. He mentioned a statement by Michael Porter, in which he said that one data product by itself is very valuable, but it becomes exponentially more valuable as you connect more assets. Do you see this happening in the power generation industry? I think it varies quite significantly geographically, but it seems that both within companies and definitely, you know, when you're talking about different companies that even if they're not competitors, it seems to be a reluctance to share data. So what are your thoughts on this? Are we going to see more like data devices being connected so we can draw conclusions from them?
I'll take that question first, if you like. So to kind of break the question down, I mean, on the closing point, if you like, about the number of connections, I can only see the amount of data being collected increasing based on any number of trends you see in the marketing, and that's also going to be driven by cheaper censoring as well. Obviously, the ability to actually generate those data points is going down in cost. There is still a slight question around collection and physical access to the data, especially if you have distributed assets within a generation portfolio, for example. So obviously there's a cost associated with the actual collection of it and then the retrieval back to the enterprise level. But my feeling is that that will be resolved sooner than later, you know, and that will just continue on a downward trend as well. So based on all of that, to answer the first part of your question about where I see big data going for generation, I think it's something that will become ever more prevalent as we move forwards, and I think as the market moves forwards as well. To kind of step back a stage further, I see the generation space is obviously evolving. Yeah, so at the moment you have traditional generation, you have renewable generation, you have small-scale DER generation, and they all kind of coexist in their own little ecosystems. Going forwards, I think that will all start to come together, either at a system operation level or potentially at a commercial level, with brokers or indeed utilities that go on acquisition sprees. So I think that integration will become ever more popular going forwards. Do I think it's that kind of tipping point's happened yet? Not quite yet, to be honest, based on what I've seen. Again, coming back to my presentation, I think there is more of that in comparable asset industries that generation firms can learn from. But yeah, I definitely think there'll be more of that in the future.
Thank you, Ian. Miguel, I don't know if you want to add to this debate.
That's a very tricky question and very important, as a matter of fact. I think the most important hurdle is not technological, because technology is off the shelf. It's over there. We have several trainees here in the company, and they bring, wow, such creative solutions using Python, R, etc. And so the thing is not around technology. We have some fellows developing sensors for noise and vibration of assets. Very, very clever solutions. So IoT is manageable. I think we have a management challenge, which is getting the right organization and the right rules. So if is anyone listening to this webinar related with this concern of getting the right organization, I have an advice. Use your first, I would say, 100 days in your job, in your new job, for getting the right data governance, the right data dictionary, because after that you will lose the momentum. The first quarter of a given data analytics department is very, very important to define the rules, the governance. And then we can start developing the models and grabbing data. So the governance is very, very, very important. The other side of the coin is related with the behavior of engineers, of technicians, and we have to handle this behavioral change, because knowledge is seen as power, or information is seen as power, and we have to manage a way to centralize data, to leverage transparency in the company, and to share information for different divisions in the value chain of a given company. The other topic that I would like to point out is related with expertise within the human resources. Because in the past, engineers were focused on conventional engineering activities, designing, simulation, commissioning, maintenance. Nowadays, each part of a company, of a generation company value chain, relates with software. A typical design engineer has to deal with software and has to deal with optimization. A grid planning engineer has to apply Python, for instance, in PSSE in order to optimize and to have probabilistic simulations. What I'm trying to say is that we have to give the right tools to our human resources in order to make these asset management transformation in the generation companies and also in the T&D companies.
So following on the cultural point, I think there's a real requirement to demonstrate the value of data as well to everybody to get that transformation going. It's an interesting one from our perspective as somebody who obviously deals into the sector. So typically most of the programs that we run either require a dedicated senior sponsor who can effectively facilitate change down the line, if you like, or a bottom-up approach where you go to the engineers and you talk to them about how they can do their job specifically better doing data, then getting that buy-in. And based on that, you can generate enthusiasm, and then everything else moves from there. And though you can get all those great structural things in that Miguel talks about. But yeah, definitely the buy-in based on the value of data up front has been very important for us.
Thank you, Ian and Miguel, for your insights into this complex question that started as one question and I made into 3 or 4. So we have actually one question from the audience from Tommy, who I believe is joining us from Chile, and he's asking what kind of new skills or knowledge are needed to get a field service engineer or electronic engineer to give technical support for customers in this new data concept space. So I suppose if we rephrase that question, what kind of skills and knowledge does a field service engineer need now to work in with big data in power generation?
I can start this delivery of answers. Yesterday I was having a conversation with one of my fellow data scientists, and he was telling me that there are 3 ingredients for data analytics or data engineering in the generation, but I would say in industries related with assets, physical assets, which is IT capabilities or expertise, maths and some simulation, statistics, and finally hacking skills. And I was quite surprised. Hacking? How come? And he told me, Miguel, when I'm trying to build a given model, I'm typically facing lots of challenges, barriers, both related with cybersecurity, organization rules, lack of data quality or quantity. So I have to get creativity to get the information following the company's rules and procedures. So these hacking skills for every engineering activity related with data management is very important, because these guys will become very, very creative, very, very prepared to address each challenge of all the process for data development and models delivery.
Thank you, Miguel.
Yeah, I would second that.
Please.
I think the other thing, I think the other interesting dynamic here is the meeting of statistics and physics, and getting people that understand both sides of the coin and people that can bridge that gap as well. You hear a lot about IT/OT integration in the asset space generally, you know, and obviously the integration of the data sets. And you hear about cultural differences between engineers and IT people. The thing I see in data science is people that are very statistically focused versus people that are very physics focused. And if you can find somebody who gets both sides of the coin, I think that's a really powerful individual you've got there.
Great, thank you, Ian. And we have a question that is, you know, not on the same vein, but it has to do with the topic. So it comes from Ayush Rastogi, and he's asking us, you know, electric utilities do territory-wide load forecasting. However, load forecasting at feeder level is usually done in an ad hoc manner. So how to get the best and the most accurate data? Do you have any answers as to that? Yeah, I'll leave it to the experts to answer. I don't know about this. Ian, please.
Yeah, I mean, I'll start off again just by talking about some of our work on a distribution level. And this is smart meter based, you'll be unsurprised to hear. So we've done quite a lot of work in the US based on aggregation of user consumption from all of that data, and then use of that to roll back up the network again, so to speak. So if you could introduce data sets such as the topology to show who's connected where, and then start to analyze your historic assumptions about load up at feeder level versus what's actually happening down at the user end. We got some really powerful results in California in particular, working on those types of problems. I managed to use that insight in a lot of the forward-looking investment programs and in things such as demand response programs as well, to lower overall usage as opposed to spending money on network reinforcement. So yeah, they're the best practical examples I would say.
I think the load forecasting is a traditional problem for utilities. For the transmission side, I think it is well addressed because we have smart metering for several years. We have 15-minute data, so I think it's not a topic nowadays. For distribution level, it's another story. But what I like to think is I'd like to raise is the following: when we will have electric vehicles, when we'll have self-consumption, microgeneration, energy storage in the distribution side, in the end user level, load forecasting at that point of time will be very, very difficult to tackle, because nowadays the consumers are quite predictable. Their behavior is quite predictable. They are rather static because they are not cost oriented in terms of the price in the wholesale market, because we don't have dynamic pricing in the retail side. So nowadays the load forecasting problem is not that challenging as it will be in the future, when we will have variable load sources, both in time and both in terms of location. We have electric vehicles moving all around the country. We'll have self-consumption and microgeneration and energy storage. And for the distribution level, it will be a very complex problem. So I think we'll have to handle it in the next few years.
I think just to an extension of the things we've just talked about, I think the biggest challenge in terms of understanding load going forwards would be the sharing of data, depending which market you're in. So obviously in a lot of countries, what happens down at that consumption end of the value chain is kept very separate from the network elements and then the people who are looking at the major generations. So we've done some work in transmission, for example, looking at the kind of impact of EVs and how that can spill back up through distribution up to transmission level again, but it was all done using, well, I say it wasn't all done, a lot of that work used publicly available data sets that people thought they could usefully analyze to solve those problems. In an ideal world, obviously they could get the required data from lower down the chain in a more granular format, but yeah, I guess there's some work to be done there in certain territories around that.
Right. Well, it sounds, you know, like getting it all boils down to getting the right data, right, and getting the real time data. I'm afraid, you know, like with all good things, the webinar is actually about to come to an end now. So we have, like, you know, a few minutes left, and so I would like to thank, you know, our audience and you, Ian and Miguel, for, you know, being sharing your insights with us today. So before we actually leave, would you like to say anything to us, you know, as parting words?
Yes, I can. Obviously, thanks very much for the opportunity to present today. Like I say, I mean, we've been working quite a lot in other parts of the utilities value chain and in other sectors as well. So if anybody's interested in those insights or indeed early work in generation, then yeah, please do reach out offline. I'd be happy to speak to you.
Thank you, Ian. Miguel, please.
Thanks, Carlos. Thanks again for the nice invitation. This was a very thrilling and funny debate. And finally, I would like to invite the audience, if there is any eager engineer related with data science, sensors development. Well, the industry is moving very fast in these topics of machine learning, of prototypes, of industrial automation, and I'm truly believing that startups and entrepreneurship will be key for the development of a conservative industry. So I think in the future we'll have lots of startups getting big in this world of power generation and transmission.
Thank you very much, Miguel. Well, before we leave, I'd like to remind our audience that the webinar has been recorded, so you'll get the recording and presentations early next week. And well, also I'd like to thank our media partners and our sponsors, primarily, you know, Sterling and Wilson, that makes it possible for us to do this type of webinar for free, to you know, so the whole industry can share in the knowledge that's being generated at the very forefront. So thank you very much, and hopefully you know, hope to see you in other webinars that we hold. Have a good day. Bye.